Dear students, this PPT is presented by Ramesh MS, Department of Mathematics, and this PPT topic is Real Analysis 2nd and Algebra 3. Learning objectives: to understand the definition of a series with examples and to understand the nth partial sum of a series and problems. Session outcomes: we'll learn nth partial sums and hence able to define series with examples and properties. Prerequisites: sequence, properties of sequence, example of sequence and problems on sequence. Definition of series. To discuss the definition of series, now it is a continuity of sequence. If you know the sequence, you can easily understand the series. In the definition of series, if un is a sequence of real numbers, then the expression u1 plus u2 plus u3 plus etc. plus un plus etc. The sum of terms of a sequence which are infinite numbers is called an infinite series. Or the sum of terms of sequence which are finite numbers is called an finite series. Totally, series having finite series and infinite series. Now, finite series having a finite number of terms, infinite series having a infinite number of terms. The infinite series u1 plus u2 plus u3 plus etc. plus un is etc. is denoted by summation n is equal to 1 to infinity un or summation un. Series of positive terms. If all the terms of the series summation un is equal to u1 plus u2 plus u3 plus etc. plus un plus etc. are positive, that is if un greater than or equal to 0 for all n, then the series summation un is called a series of positive terms. Example for the series of positive term, summation 1 by n is equal to 1 plus 1 by n, 1 by 2, 1 by 3, 1 by 4 plus etc. 1 by n plus so on. All the terms become a positive terms only, that a series become a positive series. One more example for the series of positive terms, summation n square. When n is equal to 1, 2, 3, you will get 1 square, 2 square, 3 square etc. plus n square plus etc. is a series of positive terms. Alternating series. A series in which the terms are alternatively positive and negative is called an alternating series. Now, example for the alternative series, summation minus 1 power n minus 1 into 1 by n into n minus 1 is equal to 1 by 1 into 2 minus 1 by 2 into 3 minus 1 by plus 1 by 3 into 4 plus etc. minus 1 power n minus 1 into 1 by n into n minus 1 plus etc. Now, one more example for the alternative series. Now, summation minus 1 power n into n, that is equal to when n is equal to 0, 1, 2, 3, we will get the terms. Partial sums. Consider the series summation un is equal to u1 plus u2 plus u3 plus etc. plus un now plus etc. where the terms may be positive or negative. Let s1 is equal to u2, s2 is equal to u1 plus u2. Now sum of first two terms. s3 is equal to u1 plus u2 plus u3. It means sum of first three terms. s3 means sum of first three terms. etc. Sn is equal to u1 plus u2 plus u3 plus etc. plus un. So what is on S1? Now S1 is called the first partial sum of summation un. S2 is called the second partial sum of sigma un, etc. etc. Sn is called the nth partial sum of summation un. Now we will write all the terms S1, S2, S2, S1, S2, S3, etc. Sn minus 1, S2 is denoted by sequence Sn. Is called the sequence of partial sums of summation un. Now in the multiple choice questions for sequence series, the series summation minus 1 power n is equal to 1 minus 1 plus 1 minus 1 plus 1 etc. is A. Just I will say there that the series in the first terms become a 1, second terms minus 1, third terms minus plus 1, fourth terms minus 1, fifth terms plus 1 etc. There is the terms you will observe it only positive, negative, positive, negative. When the alternate signs are present only, that series, we say that series become a alternative series only. But you'll see the answers now, a series of positive terms, a series of negative terms, alternating series, none of these series. A series of positive terms means if all the terms of the series is having a positive, that is a series of positive terms. If all the terms of the series having negative, that is a negative series. Alternating series means a series having positive, negative, alternate series, that is the answer, alternate series. But answer of this series is answer C, alternating series. Answer C. Now in the second one, second partial sum of the series n is equal to 1 to infinity 1 by n into n plus 1 is second partial sum of the series. First partial sum of the series is u1. u1 is equal to n is equal to 1. When n is equal to 1, 1 divided by 1 into 1 plus 2, 1 divided by 2 only. That is the first partial sum. S2 is the second partial sum. But second partial sum means sum of the first two terms. Sum of first two terms means when n is equal to 1, that is a 1 by 2, plus n is equal to 2, 1 by 2 into 2 plus 3, 1 by 6. 1 by 2 plus 1 by 6. We will take that, simplify that values on there, we will get answers on there. That is a 7 by 6. 7 by 6 is the answer. Now how to finding the second partial sum when n is equal to 1, that is the first, S1 is equal to u1, that is the first partial sum. N is equal to 2, that is a u2. u2 is equal to n is equal to 2, but S2 is equal to u1 plus u2. What is on u2? u2 is become a 1 divided by 2 into 2 plus 1, 1 divided by 2 into 3. 1 by 2 into 3 means 1 by 6. When add these two terms, 1 by 2 plus 1 by 6, that is an terms only. If you take LCM of the two terms only, now LCM is 6 LCM. Now 6, 2, 6 cancel, 3 is a 2, when you cancel 6 3 times, 3 into 1, 3 plus 6 1s are 6, 1, 6, 1s are 6, will be cancelled. Now that is equal to 3 plus 1, that is equal to, that is the answers. Answer become a 7 by 6. Just you will verify yourself. An infinite series of the terms, infinite series of the form n is equal to 0 to infinity Cn into x minus a power n is called a dash series in x minus a, where a is constant called a center of the series. Now n is equal to 0 to infinity Cn into x minus a power n. Just I will give it power n. Just you will verify that series. That series become a now power series, alternating series, Taylor series and Maclaurin series. Answer become a, now third one, power series. An infinite series of the form, an infinite series of the form n equal to 0 to infinity Cn into x minus a power n is called a power series in x minus a, where a is a constant called a center of the series. Nth partial sum of the series. So how to finding the nth partial sum of the series? 1 divided by 1 into 3 plus 1 divided by 3 into 5 plus 1 divided by 5 into 7 plus etc. is. Now just we will verify the series. Now how to finding the nth partial sum of the series? Just we will take first terms 1 by 1, 1 by 3, 1 by 5 plus etc. Just we will take another series 1 by 3, 1 plus 1 by 5 plus 1 by 7. Now in the denominator, in the first terms in the denominator 1, 3, 5, 7. 1, 3, 5, 7. Just you find the nth terms of that sequence. Now when a is equal to 1, in the common difference 2 and number of terms, we don't know the nth number of terms. When apply the formula Tn is equal to nth terms, Tn is equal to a plus n minus 1 into d. When a is equal to 1 plus n minus 1 into d, d is equal to 2, substitute all the terms only 1 plus n minus 1 into 2. When I multiply into 2, 2n minus 2 are the terms 1 plus 2n minus 2 is equal to 2n minus 2 plus 1, 2n minus 1. It is the first terms. 1 divided by 2n minus 1, first term. What is the second terms? Now 3, 5, 7 are there. 3, 5, 7 etc. are the sequence. In the first terms become a 3. Now in the common difference become 2. We will apply the formula Tn is equal to a plus n minus 1 into d. Now that nth terms is equal to a plus n minus 1 into d. A is equal to 3. D is equal to 2. Just now when I substitute a and d, 3 plus n minus 1 into 2, 2n minus 2, 2n minus 2 plus 3 are these two terms, 2n plus 1, that is the nth terms. Just you will see the answers for the nth terms. Summation n is equal to 1 to infinity 1 by 2n minus 1 into 2n plus 1. Now next answer b become n equal to 1 to infinity 1 by 2n plus 1 into 2n plus n plus 5. Now n is equal to 1 to infinity 1 divided by k minus 1 into k plus 1. Now n is equal to 1 to infinity 1 by k minus 1 into 2k plus 1. Now instead of k or n, both are same only. Now just you will see the answer become a. Now nth terms of the series become a answer. Find the second partial sum of the series. Find the second partial sum of the series n equal to 1 to infinity sine inverse of 1 by n minus sine inverse of 1 by n plus 1. Second partial sum of the series. First partial sum of the series is S1. S1 is equal to U1. Second partial sum of the series S2. S2 is equal to U1 plus U2. So first we have to finding U1. U1 means n is equal to 1. When you give the n is equal to 1, sine inverse of 1 by 1 minus sine inverse of 1 by 2. That is the first terms. Sine inverse of 1. Sine inverse of 1 is equal to pi by 2 minus sine inverse of 1 by 2. It is the U1. When n is equal to 2, U2 is equal to sine inverse of 1 by 2 minus sine inverse of 2 plus 1 sine inverse of 1 by 3. That is an U2. First partial sum means S1. S1 is equal to U1. But in the question will be find the second partial sum of the series. Second partial sum of the series means S1 is equal to U1 plus U2. When you substitute the values of U1, what is an U1? U1 become a pi by 2 minus sine inverse of 1 by 2. What is the values of U2? U2 become a sine plus sine inverse 1 by 2 minus sin inverse 1 by 3 plus sin inverse 1 by 2 minus sin inverse 1 by 2. These two will be cancelled. Now in the remaining values become a now pi by 2 minus sin inverse of 1 by 3 is the second partial sum of the series. Just you will see that answers. Now sin inverse 1 by 2 minus 1 by n, it is not an answer. Pi answer B, verify, pi by 2 minus sin inverse of 1 by 3 is an answers. Pi by 2 minus, just you will say the answer C, pi by 2 minus sin inverse of 1 by 3 is a correct answers. Now reference for the this PPT topic is textbook of mathematics by G.K. Ranganath, principle of real analysis S. Malik, a first course in real analysis by Alpha Signal and M.K. Signal. Thank you.